Okay, so we're going to look at a new Power Series worksheet. We'll call it Power Series A. And the first problem we're going to look at is this one. Consider a function f of x equal x times the natural log of the quantity 5 minus 2x. We're going to start and end with this f of x, and our goal is to find the Power Series representation of f. There's going to be some intermediate steps. The first one, we're going to take just the natural log part and take the derivative of that, because that type of function, let's call it g of x, we will be able to find its power series representation. So we're going to take this natural log part, take its derivative, find its power series representation. Then if we integrate that, we should get back to this natural log of 5 minus 2x. So we're going to take that power series, we're going to integrate it to get the natural log of 5 minus 2x, but then we're going to have plus some constant, because when you integrate, you get plus c. You need to solve for that c. So we're going to need to solve for that c. Then that function that we get, antiderivative plus whatever the c value that we get, that equals natural log of 5x, 5 minus 2x on the interval of convergence that we get from part B here. And we're not looking for that function, we're looking for f of x, which is x times that. So then we're going to take that power series plus the constant and multiply by x, and we'll be done. Okay, so let's stop sharing there. I'm going to open up my whiteboard here. So our original function f is x times the natural log of 5 minus 2x. And the problem wants me to say, okay, well, let's look at g of x being the derivative, not of f, because that involves the power rule, the product rule, but just of this natural log part. And if I can take the derivative of this and then find its power series representation, then I can take the antiderivative of that to get the ln part back, and then we just multiply by x and we'll have f. Oh, so this is part A. Derivative of that is 1 over 5 minus 2x times -2. To get this in a power series format, I'm going to pull this -2 on top to the front, and on bottom, I'm going to factor this 5 out. So -2/5 times 1 over, I'm factoring that 5 out, so we get 1 minus 2/5 x. This guy is now in the form that I can get the power series representation of, because this is just equal to -2/5 times the sum from n equals 0 to infinity of 2/5 x to the n on the absolute value of 2/5 x less than 1. That's the first part. Let's see if I can grab that menu here, scroll down. I'm going to draw a line. So that's the derivative of the natural log. And then maybe there's one more step in here where I'm going to rewrite this g of x as negative the sum from n equals 0 to infinity of this. I'm going to bring this 2/5 in because it matches that 2/5, but leaving the negative out. So 2/5 to the n plus 1 times x to the n. And we're going to come back for this interval of convergence. It's actually done. Multiply it -1 less than 2/5 x less than 1, multiply through by 5/2, and our radius, our interval of convergence for everything is from -5/2 to 5/2 for all the functions that we deal with. Okay, so here's my little g of x, which again is the derivative of that natural log. So I'm going to then, okay, take the antiderivative of that to get back to the natural log, but I'm going to have plus a constant involved. So capital G of x will be the antiderivative of little g of x dx. So what we're going to do is antidifferentiate this sum, but we're going to just leave the sum and we'll antidifferentiate each piece. So it's from n equals 0 to infinity. The 2/5 to the n plus 1 is a constant with respect to x. So we're integrating x to the n, whose antiderivative is 1 over n plus 1 times x to the n plus 1. So we're just taking the antiderivative of that. Antiderivative of that is 1 over n plus 1 times x to the n plus 1. And in a sense, that's my g of x, capital G of x. But we also get, plus a constant. So if we think about, we take the derivative, then the antiderivative, you get back with what you started with. In other words, we get back this natural log function. So the natural log of 5 minus 2x, it says it's on the worksheet, is going to equal this g of x plus a constant. G of x plus this constant here. Okay, so we have to figure out what this constant is. So, and I'm just, maybe I moved the c to the wrong side, whatever. Okay, so what is that constant? Well, what we do, and did this in class, but I did it badly. We choose any value of x. So a nice value of x is 0. So if I plug 0 into the power series on the right, when we plug 0 in here, this first term is not 0 to the 0, it's 0 to the first, which is 0. And every term after that is 0. So the entire sum is 0 plus this constant. On the left, when I plug 0 in, I get ln of 5 minus 0. That's just ln of 5 has to equal 0 plus the constant. So that constant c is ln of 5. In other words, ln of 5 minus 2x is this power series, the sum from n equals 0 to infinity, 2/5 to the n plus 1. Maybe we would put the 1 over n plus 1 in front, 1 over n plus 1, just to make it look better, times x to the n plus 1, and then plus this constant ln of 5. And so we've sort of differentiated and then integrated and then added this constant on. And then back up to the original problem, my f of x is x times this. So back down here, f of x, let's draw a line. This would be the last part. F of x is x times that. So we need to multiply all of this by x. So I multiply the first part by x. That gives us the sum from n equals 0 to infinity, 1 over n plus 1, 2/5 to the n plus 1. And when I multiply by x, I just increase this power of x by 1. So it goes x to the n plus 2. And then it's going to be plus, I need to multiply this term by x ln of 5. And then all three have the same radius of convergence, which we already found. Negative 5/2 to 5/2. Negative 5/2 to 5/2. So it can be a little confusing, the process. And, ultimately I could have just asked this f. It's very hard, really, especially if we're just learning this material, to just start with this random function f. So we have this random function f, which is x times natural log of 5 minus 2x. We then break it into pieces, starting with looking at just the natural log part. But what we don't want, we want that natural log part, but we really just want the derivative of that, because its derivative is something that I know how to make the power series representation of. So we then take the derivative, find the power series representation, then we can anti-differentiate that power series term by term. That's the step going from little g to capital G. We then need to find this constant c because it varies when you take an antiderivative. So we do that by plugging a value of x in, usually 0. With the whole sum going to 0, because this is 0 to the first, 0 squared, 0 cubed, everything 0 to a power besides 0 to the 0 is always 0. So, and then we find that c, and then that's ln of 5 in this case. So the natural log function is all of that power series plus ln of 5. And then the original function was x times all that. So I just multiply power series by x, which raises this power from n+1 to n+2. And then we still have to have this x times ln of 5. Interval or radius of convergence is the same for all the power series on here. Okay, that's part one. I'll do one more, and that'll be it.